Okay, we're going to take a look at number 8 in section 4.1. We're going to consider this polynomial function here, and we're going to determine the linearization L of this function at a equal 1/2. Express all numbers in exact form, so that means no decimal approximations here. So what is the linearization? Well, the linearization for the function is L of x is equal to all this. If you look at, in the textbook, look at the formula for this. But remember from the lecture what this actually is. This is just nothing more than the line tangent to the function at x equal a, in this case, a equal 1/2. So again, in general, when we have how do we find the equation of the tangent line? We have the given point, right? A comma f of a. The slope is what? The derivative of the function at a. And then here is my equation of my line, right? And I just plug in those values. The given point, right? X1 is a, Y1 is f of a, and the slope m is f prime of a. So if I plug in those values, I get this right here, which if I add f of a to both sides, gives me this, which if you look up here, this is exactly the linearization. So linearization is simply the equation of the tangent line. So that's what we're doing. We're approximating, again, this function by its linear function, or by the linearization by its tangent line, which is important because, again, a linear function is much more simpler, for instance, than a degree 4 polynomial function. Okay, so what do we need here? We need f of a. Remember, in this problem, a is 1/2. So I'm just going to plug in 1/2 into this function, and I've done that here. Okay, you can use your calculator, but again, you want it to be an exact form, so no decimal approximations. So I just went ahead and did this. 1/2 to the 4th power would be 1/16. 1/2 cubed is 1/8. 1/2 squared is 1/4. And then I've got 3/16. 12 times 1/8 is 12/8, which if you divide top and bottom by 4 gives you 3/2. 6 times 1/4 is 6/4, which if you divide top and bottom by 2 gives you 3/2. So I just have you note 3/2 plus 3/2, these are 3, right? 3/2 being 1 1/2. So this is just 3. And then 7 times 1/2 is 7/2. So that's negative 7/2 plus the 12. So all I did is I noted if I'm going to combine these as one fraction, I need a common denominator, which is going to be 16 is the least common denominator. So I've got 3/16. Here I just said, well, the negative 7/2, if I, what do I need to multiply 2 by to get 16? Well, the answer is 8. 8 times 7 is 56. So 56/16, that's the equivalent fraction there for negative 7/2. And then plus, I just added 3 and 12, which is 15. What's 15 over 6? What would be the equivalent fraction? Well, it's 240 over 16. 240 divided by 16 is 15. All right, so these are all equivalent fractions. Now I can just do 3 minus 56 plus 240 is 187. Okay, bottom line, and some of you have a convert to fraction button on the calculator. That's fine, but make sure you give the exact form. Now we do need the derivative, right? In this linearization for the slope of the tangent line. And again, we're going to find the derivative of this function. So what do? I bring the 4 down. That gives me 12x cubed, which is what I have down here. And then the derivative of 12x cubed is bring the 3 down, 36x squared. And the derivative of 6x squared is 12x. Derivative of negative 7x is negative 7. Derivative of 12 is 0. So that gives me this derivative here. And now I just need to find f prime of a, right? So a again is 1/2. So I just plug in 1/2 into that. And I do all the work and you get 19/2 for that. Okay, so plugging that in, then the linearization is going to be f of a is 187/16 plus f prime of a, the slope, which was 19/2, times x minus a. Remember, a is 1/2. So here's linearization. If I distribute the 19/2 through, I get 19/2 x minus 19/4, and then 186/16 minus 19/4. You can see that that's 111/16. And here is your linearization. I think in the problem, you're just entering this part in. They give you, this equals, and then here's the box. But again, this is just the equation of your tangent line. Y equal this is the tangent line to the graph of the original function at x equal 1/2. Okay, so I hope this is helpful.